virtual work is applicable to determine knot deflection in truss. Let's say we have a 4-panel Warren truss with total span of 12 meters. The truss members are made of structural steel and let their cross-sectional area be 3000 mm square. The truss is loaded at 3 bottom chord knots, each of them with magnitude of 100 kN. What will be the deflection at knot C? We need to solve for the member forces to proceed. To do so, we need to determine the support reactions. For symmetrical truss like this, the vertical reaction at each end should equal to half of the total applied load. Then, to calculate member forces, we may use method of joint. Thanks to the symmetrical nature of the truss, we only need to go through left half of the truss, and by mirroring it, we can still get the accurate result. Similar to virtual work method for beam, to determine deflection at any knot of truss, we need to assign a unit virtual load there. Then, we calculate the member forces under the virtual load case. By using the results for both real and virtual cases, we can apply the equation below and determine the deflection at target knot. Let's repeat what we have done for real load case. First, we determine the support reactions. Then, we implement method of joint again to determine member forces. At the end of this process, we should tabulate the member forces under both load cases and make our upcoming task easier. Next, we determine the length of each member and insert it to our table. Finally, let's put in the cross-sectional properties of members. Now, it is time to calculate the value of NNL over AE for all members. After the calculation, by summing all the calculated values, we obtain the deflection at knot C. Positive deflection value denotes the direction of knot deflection is the same as the direction of virtual load. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.